Hi everyone, welcome to Veteach. So in the previous session we had discussed about how to measure pressure by using piezometer and YouTube manometer. Now let us see how to measure pressure by using single column manometer. So what is single column manometer? So single column manometer will have a reservoir and we will have one limb or one column. If you see, a single column manometer is just a modification from YouTube manometer, which a reservoir having a large cross section area which is like 100 times more than the cross section area of a YouTube. So if there is any change in pressure in this pipe A, the level of manometric liquid in the reservoir is small and the change in level of mercury in that liquid is the YouTube manometer is large. So the other limb may be vertical or inclined. Thus, there are two types of single column manometers. One is vertical single column manometer and another one is inclined single column manometer. Fine. So, if you see the in detail about single column manometer, so let us think the pipe center is a distance h1 from the reservoir center and the mercury in the right limb is similarly h2 distance and delta h is fall of the heavy liquid in the reservoir. H2 is the rise of heavy liquid in the right limb, which is mercury, and H1 is the height of the center of pipe from or above XX. Next, what PA is the pressure tip point which is going to be measured, and capital A is the area of the reservoir, and small a is the area in this right side limb, and S1 is the specific gravity of the liquid in the pipe, and S2 is the specific gravity of the heavy liquid, that is we are going to take as mercury. So, as we know, fall of heavy liquid in the reservoir will cause a, right, as if you see, if there is any falling of the liquid in the reservoir, there is some simultaneously there is a rising of the liquid in the right limb also. Okay, so for that, what is the volume in the reservoir? A into delta H, which is equal to small a into H2. So A is the area of the reservoir and delta H is the fall of the liquid and H2 is the rise of the liquid. So A into delta H is equal to small a into H2. From that, delta H is equal to A into H2 by capital A. Now consider this YY as my datum line and try to write the equation. So if you see the pressure in the left limb, so if you see the pressure in the left limb will be PA plus the pressure up to this distance, lighter liquid, that is rho 1 GH1, and the pressure in this small part also. In the small part also, the density is rho 1 only. So the equation will be rho 1 G delta H plus rho 1 GH1 plus PA. And the pressure in the right side limb will be, if you see in right side, there is only one liquid, that is of also a heavier liquid, that is manometer, that is the mercury, and it is having a density rho 2 and it is having a height h2. So the pressure in the right side limb will be rho 2 g h2. Now equate this pressure to the left side pressure, this, so we will get the equation. So from this we can find easily PA. Now as we already find out delta H value in one above equation, so delta H is equal to A into H2 by A. Substitute this here. If you see, as the area is very large compared to small a, hence the ratio of small a by capital A is become very small, so this can be neglected. Okay, so now what we left with? We left with PA equal to H2 into rho 2g minus rho 1g plus rho 2g H2 minus rho 1g H1. If you multiply H2 inside, so what we will get? We will get this rho 2g. So if you multiply this H2 inside, what we will get? H2 rho 2g minus H2 rho 1g plus rho 2g H2 minus rho 1g H1. So this is the equation we left with. If you solve this equation, we will get PA equal to rho 2g H2 minus rho 1g H1. As it is clearly seen that H1 is known, and hence by knowing H2, that is the rise of the heavy liquid, the pressure PA can be easily calculated. But if you want to calculate the pressure in the point PA with high accuracy, so what we will do is we will use a inclined single column manometer. So here what will happen? This is the equation for change for finding pressure PA with respect to a vertical column manometer. But what is height H2 here? So I want to find the relation between H2 and L. So this is the length L of the mercury, or else length L is the height of the or length of the column in the right side limb, and this is my height H2. and this is making an angle theta with horizontal. Let us make a triangle here like this. So if I apply sin theta formula, sin theta equal to opposite h2 by length L. So h2 will be L sin theta. So substitute the h2 in this equation, you will get pressure PA equal to sin theta into rho g, rho 2g minus rho 1g h1. Okay. So here it is L sin theta. Fine. Next one is differential manometer. So differential manometer are used to find the pressure difference between 2 points in a flowing area. So we have two types of differential manometers. One is U-tube differential manometer and another one is inverted U-tube differential manometer. Fine. So this is U-tube manometer. This manometer is used whenever the point A and point B are at different levels, and this is used whenever they are at same level. And if you see, this is for this is not open to what we called atmospheric pressure, so there is less chance of occurring vacuum pressure here. If you see, the mercury is looking like my gauge pressure condition. So let us write the equation for pressure in the left limb by applying Pascal's law. So pressure in the left limb will be Pa plus let us take the density of this liquid in the column A is rho 1. So the pressure due to this height will be, so what is the height of this? So up to here it is x and up to here it is h. So it will be rho A g, height is x plus h. So this is the pressure in left limb for this one, and the pressure in the right limb will be Pb plus, so we have to find the pressure due to liquids above the datum, that is, this is one liquid and this is another liquid. Okay, let density at the lip of the liquid B is rho 2, so it is rho 2 g y plus there is another liquid and this is my higher density liquid which is nothing but mercury, so it will be rho m g h. So this is how we will equate left limb pressure with right limb, and if I take this PB left side and if I take this equation to right side, I can easily find the difference between pressure PM minus PB. Similarly, try to apply this equation to the U-tube differential manometer. When A and B are at same level, you will get this type of equation. Inverted U-tube manometer. So what is inverted U-tube manometer? It consists of an inverted tube containing a light liquid. Then the two ends of the tube are connected to the points where we are finding C. So one end is connected to the point A and other end is connected to point B. It is used for measuring differences of very low pressures. So if we try to apply the equation for this inverted U-tube manometer, so the pressure at point A will be PA. So when you are applying minus, so previously as change in pressure in downward we had taken plus, so here we have the change in pressure, upward we are taking it as minus. So PA minus height of pressure due to height of H1 column is PA minus rho 1 GH1 is equal to, the right side pressure is PB minus rho 2 GH2 minus rho mgh or rho g. Whatever we take the density of the manometer measuring liquid, we will use the density here. So this is how we find the pressure difference between 2 points by using a U-tube manometer and by using a differential manometer. So in this introduction part, we had covered different fluid properties like mass density, weight density, specific volume, and we also discussed specific gravity, viscosity. In viscosity, we discussed Newton law, non-Newtonian law, okay, types of fluid, and later we discussed about pressure, different types of pressure, atmospheric pressure, gauge pressure, vacuum pressure, and then we discussed measurement of pressure. So with this, the fluid properties and pressure measurement concept was completed. In next session, we will solve some important and good problems on these topics. Thank you for watching.